So many people are interested in modeling the ecosystem services produced by forest ecosystems. But in many cases, those models treat forests as a static layer, often assigning constant values for important services like carbon storage to different cover types. Now, not all models do, but for those that do treat forests this way, I find some of the predictions regarding ecosystem services to be a little bit questionable. So with my talk today, I'd like to address one key point with three parts. First, forest ecosystems are dynamic over time and space, and therefore the services they provide will vary accordingly as an output of those dynamics. So it's best whenever possible to model forests as a dynamic layer. Take, for example, carbon storage in the world's forests. Here are 4 examples of temperate forest ecosystems from different parts of the world. And my colleagues and I have shown that not only does carbon storage accumulate and develop over time as forests age, but it's also highly variable within those chronosequences. And in many cases, this range of variability is actually greater than the contrast between forests and non-forest vegetation. Moreover, management has an overwhelmingly dominant effect on carbon sequestration and storage on forest landscapes. Here are 9 different management scenarios projected forward in time for northeastern forests. And again, I want to call your attention to the fact that the range of variability within these is actually greater in many cases than is the difference between forest and non-forest vegetation. So if your ecosystem service model doesn't capture these temporal dynamics or management influences, there's a pretty good chance that you're misrepresenting carbon storage on your landscape. Forest ecosystems are dynamic over time and space. The services they provide will vary accordingly. It's best whenever possible to model your forest as a dynamic system. My lab has done a lot of work on disturbance effects and how those influence ecosystem services. And we know that forest structure and function is shaped over time by the compounded interactions of finely scaled natural disturbances superimposed on periodic intermediate intensity disturbances. These play a critical role in lots of different services that we care about. So take, for example, woody debris recruitment into stream channels. We know that woody debris is really important for habitat formation processes. It increases roughness coefficients in streams, which play a role absorbing energy during flood events. And woody debris recruitment is also related to forest development over time. But note again the range of variability here that reflects disturbance processes in riparian corridors. Disturbances create spatial complexity in forests. And I've been able to show that spatial complexity itself, if you think about patch mosaics, for instance, is also related to things like geomorphic integrity in stream channels, measured here with RGA and shown here with the standard deviation of basal area. Now, if geomorphic integrity in turn reflects things like sinuosity and channel complexity, we know those things are really important for services like flood resilience. So it's really important, if we're modeling that, to think about those dynamics that are happening up there in the forest, even if what we're trying to model is happening down here in the river channel. Forest ecosystems are dynamic over time and space. The ecosystem services they provide vary accordingly. Model your forest as a dynamic layer. Thank you very much.